According to our observation, nothing in this universe in permanent. This observation can be made like in the nature or in the universe itself. Nothing is permanent. Even the universe has its fate. In the Big Rip or Big Bang. The heat death of universe, like that. So nothing in this universe is basically permanent. Same applies to the black hole even. And black hole, you know, perishes via Hawking radiation. It evaporates. It loses its mass. It's not something which is permanent, as universe itself is not permanent. What is Hawking radiation? Let's start that. So at tiny scales of space-time, at very short intervals, the uncertainty in energy is higher. That is what Heisenberg's uncertainty principle says. So when you have this uncertainty in energy, let me tell you what happens at the tiny scales of space-time. So let's say we have some zero energy density. That in reality that is not possible. That is not really possible. So because there is always some energy, we can't really achieve zero energy anywhere in this universe. It's never gonna happen, and it's never like this in this universe. So basically, but let's take in this example, we have some zero energy density over here. Then at the tiny scales of space-time, there get created a pair of particle, let's say an electron and positron, which get created from nothing, and which approach when it get created, it again approaching each other electromagnetically, as there is some electromagnetic force between a positron and an electron, until they get enough near, and after which they annihilate each other, and creating and radiating after that, and returning the universe its energy. And that is also not a law of violation, as one may uh, claim that is the violation of the first of thermodynamics, that the total energy mass, the total energy in this universe should remain constant. But even if there is a violation of this law, it's just momentarily, and it's for a very short amount of time, and eventually we have the energy borrowed from this universe returned to it. Just that occurs just in short amount of time. So that's completely okay in that case. But to consider the same scenario of this creation of virtual particles near a black hole, the scenarios, in this case we have no energy return in case of radiation. In terms of radiation, like those black hole don't really allow those two virtual particles to meet each other and radiate again. So what happened in this case is that when two particles are on the verge of annihilation, one of these two virtual particles get inside the black hole, and one of it lives. Let's say an electron or positron get inside the black hole, or both on one of both of them lives the black hole, escape the black hole. But where does that escaping energy get from? Why is now why are both particles not getting fell inside the black hole? Why is one of them is getting inside, and one of them is thrown out? That's due to the tidal gravity of the black hole. It has a stretching effect, the same effect the moon has on the earth. That's why we have the waves. And comes in near the black hole, it is is very known as is highly known as famously known as the spaghettification, the effect of spaghettification. Like it stretches, it creates, it spaghettifies any object. For example, this pen, it will just spaghettify if it gets near the black hole. And so it applies to everything which has which are long enough to get again spaghettified into super long things. And so we have this effect of spaghettification or effect of tidal gravity, which not allow these two particles to get near to each other and again annihilate and radiate. And what we have is one of the particles gets inside the black hole, and another lives it or escapes it. This escaping particles which escapes the black hole is what we call as the Hawking radiation. This Hawking radiation is borrowing this escaping energy, the escaping velocity, whatever it has, this energy which it has, by which it is escaping a black hole, near black hole, at it's escaping the point which is near to the black hole. The energy it gets, it comes from nowhere, but the black hole itself, the mass of the black hole itself is, converted into energy, given energy to that particle to escape, that particular point which is near the black hole. So technically, the mass of black hole is decreasing as there's so much space around the black hole. Black holes are very, large in sizes. They will very large from sizes, from microscopic to, to the size like, bigger than the solar system itself. And so if to consider the black holes, like, which are large in the solar system, there's so much, space around them, and there's so much popping of the virtual particles into the existence, and one of which, get inside the black hole, other gets, Hawking radiation. But in reality, actually, even if the black holes, get evaporated in terms of Hawking radiation, it will take like so much time, maybe like, even the what our current age of universe is, it may take even much longer than that. This time it will take much longer than this time for a black hole, like a larger black hole, to evaporate into the Hawking radiation. This is what Hawking radiation is, and this is how, not if every, but many of the black hole have their fate, in this universe. And that's the only fate, I guess. Like, the reason I told you not many, like, because now, like, in this universe, even if some black holes, get sustained till eternity, then they may still take longer, and we may have just collapsing this black hole into something like big crunch or something like that, in the eternity over there. So we may not comment over the Hawking radiation during that time, because that time these black holes are enough old, to get the Hawking radiations of into the universe until the big crunch crushes them into what you call again the singularity, something like that. We'll discuss it later. So it's just that the black hole had its fate, and in the, you know uh, it just, perishes in terms of the Hawking radiation. That is what Hawking radiation is. Hope so you guys enjoy this video. If you have any question, just comment in the comment section, subscribe my channel, and thank you everyone to listen to, carefully, and be patient to, listen my video and watch my video, I mean. Thank you everyone. Bye.